perfect square trinomials are trinomials that once factored, both factored parts are identical. Hence, they're called perfect square. So the shortcut means that your factor can be written as just a single factor, but notice it is squared. That's where perfect square trinomial comes from. So if we look at these examples, this first term here is a perfect square. This back term here is a perfect square. That is a good indication, since both the first and the last terms are perfect squares, that this whole thing is going to end up being a perfect square trinomial. Now, that's no guarantee. However, it is a pretty good indication that that's most likely what you're dealing with. So here we can go ahead and factor it into its parts using whatever method you will choose. This right here is setting up for you to do the idea of reversing your FOIL. So my first term is a z. So when I break that, it becomes z and z. Notice my back term is positive. So remember, this tells you what your options are. And so as a refresher, when we're looking at your options, we have a couple things. If you have a back term that is positive to get there, that means you've got positive times positive to get that positive result. Well, the other option you have is negative times negative gives you that positive result. In order to figure out which option you have to use means you need to look at your first sign. Since this sign is positive, that means that the option here that we are going to use is the positive positive option. Therefore, positive positive goes into your equations. Now the last thing to look at is the fact that we have this 81. So when we're talking about perfect squares, the perfect square of 81 gives you a 9. So my guess would be that these have to be 9. Now if you were to FOIL this back out, the hope is that we end up with an 18z here in the middle. So we would have z times z, which is z squared, z times 9, which is 9z, and then repeat it, z times 9, which is a 9z. So if you look at just the outer and the inner piece, our goal is that it gives you the 18z. So here we end up with 9z plus 9z, which is 18, so we did it right. Now because this is perfect square and mathematicians are inherently lazy, we like to then write this factor just simply in its reduced form, which would say that we had z plus 9 and we would square it. Let's look at a different one. So here, notice again, my first term is a perfect square. My back term is a perfect square, so it's a pretty good case again that this is going to be a perfect square trinomial. So when we're looking at it, the first thing that we need to consider is your options. So again, we would have positive times positive gives you a positive. We can have negative times negative gives you a positive. Or we can have positive times negative giving you a negative. So we need to know what we have to choose. This back term here tells us which one of these options here to choose. And then the middle term here tells us which one we have to pick. So here we're going to choose the negative negative option. Now, obviously, when we're dealing with perfect square trinomials, we don't want to end up with this bottom term, because if we do, then notice my factors are no longer identical. So what we really want is we want this back term to be positive so that we end up with one of these two positive positive cases. Now here, once we figure out what it was, we can simply look. We have 9x squared. So when we reduce this by the square root, we're going to end up with getting a 3x. And then we have a 4, which again, when we reduce by taking the square root, you end up with a 2. And so here, if you look, notice my solution would be a plus b squared. Keep in mind, this can also be a minus b squared. And so here, instead of actually writing the two factors together, we would simply create that this term here is my a, this term here is my b, and thus we would have 3x minus 2 squared. So notice both of these are perfect square trinomials. In this first one, I just went ahead and factored it down to its parts and rewrote it as its perfect square trinomial piece. In the second one, we looked at it more theoretically, or whereas instead of actually factoring it, we just simply took it from its known ideas down into its parts. Either way you approach the problems, you're going to end up with the same result, so you need to approach it however you feel the most comfortable. So that being said, let's just take a look at a couple more examples here that might not be quite as obvious as the first two. So here I have x to the 4th plus 10x squared y plus 25y squared. So, ignoring this middle piece, we have to look at just this front part and this back part. And when doing that, you essentially are asking, are both perfect squares? That's what you're asking. And in this case they are. I have x to the 4th, which we know can reduce down, and I have 25y squared, which also can reduce down. So here, my x to the 4th, when I reduce by taking the square root, I end up with x squared. And then I have 25y squared, which again, when I reduce by taking the square root, I end up with 5y. So here again, just like before, this x squared here would be your a, this 5y is going to be like the b, and the last thing we have to do is we need to take in mind the signs. So again, this sign right here tells you that the option you need to use is the positive option. So here we can write our perfect square trinomial in being x squared minus 5y and square it. Sorry, plus. Now if you were to actually multiply this all back out, you will actually get what you started with here. Okay, let's do it one more time. So this one here, I would start by removing a GCF, and in this case we can remove out a 3. Once we do that, pull that 3 out, we are left with 16x squared minus 40x plus 25. Again, if we take a look at them, you can see that this first term here is a perfect square, and it will reduce by taking the square root down to a 4x. This one over here is also perfect square and will, as the same, reduce by the square root, and it becomes a 5. And now the last thing that we need to pay attention to is we need to pay attention to my signs. So this back term is positive, so this is exactly what we wanted. This front term here, This tells us that we have to use the negative option. So what we actually have is we have a 3 on the outside. Then we have 4x minus 5 and square it. Alright, so there you go. There are 4 different examples of being able to reduce down what are called perfect square trinomials down into their perfect square form. So if you have any questions, please let me know. Otherwise, keep smiling, have tons of fun, and I'll see you next time.